Thank you for joining me today. We started this week talking about measuring of concrete formwork and steel rebars. Just a quick review. If you would like to figure out the quantity takeoff of formwork, it will be calculated in area basis, square feet, square meter, whatever the unit, but area in square feet or meter. Keep in your mind, if you would like to figure out the area of the formwork, you have to figure out the area adjacent to the concrete surface. If you are talking about footing, we need to figure out the area of formwork on these four sides: this side, this side, this side, and this side. That's it. The bottom is supported by the soil, by the earth, by the ground surface, and the top is open. The top of the footing is open. So we have technique that we learned that if you would like to figure out the surface area of the sides, you can get the perimeter of this square or this rectangle. Side times 4 if it's square, or width plus length times 2 if it's rectangle. Then you need to multiply this parameter by the thickness of the footing. This is a technique to figure out the surface area of the four sides. If you are talking about beams, I will consider the beam, your beam is rectangle. I will consider the area of the four sides, this side, and this side, and the bottom side, because the top side will be open. As you see here, this top side is open. I have this side and the opposite side and the bottom side. So keep in your mind, your beam formwork will be this area of this side, and we have another area for this side, and we have bottom area for the bottom side. That makes sense? For columns, we will figure out the total area of the four sides. This one, and this one, and this one. I do recommend, if you would like to figure out the total surface area of the four sides of the column, go ahead and find out the perimeter of the cross section. What is the perimeter of this cross section, if it's a rectangle or square? Then multiply this perimeter by total height of the column. If you multiply this area of the cross section by the total height, the perimeter of the cross section. The perimeter of the cross section times the total height of the column, you can get the surface area of the four sides of this column. For slab, you need to figure out the surface area of the slab where you will pour your concrete. Just length by width. For walls, mainly, I need to figure out the two sides, this side and the opposite side. If you would like to make more accurate calculation, we need to consider this end side besides the two big sides. Let's do this example with you. We have isolated footing with a column. You need to understand what is the meaning of this drawing and what is the meaning of this drawing. Keep in your mind, this is called elevation, and this is called plane. In the real life, for 3D, this looks like this. We have a footing, looks like this. And we have a column looks like this. That makes sense? If you watched this column and the footing from this side, you are standing here and look to the footing and the column, you will see this elevation. If you are at the top and you are watching from this side, you will see the plane. Elevation and the plane will be given so you can imagine what is the isometric looks like. That makes sense? This column and this footing is to be constructed. Please conduct net in place quantity takeoff for the formwork of the footing and the column. So we need to figure out how much area for the formwork for the footing. As I mentioned before, for footing, we need to consider the four sides, this side and this side, and the same, this side and this side. If you would like to figure this out, that means I need to figure out the perimeter of this footing, this length plus this length plus this length plus this length, and then I will multiply it by the thickness. Can you figure out this information from the given drawing? We should. From the plan, here is the footing. If you look to the plan of the footing, you can find the square. Is it square? Yes. This side is 3 feet and 2 inches, and this side is 3 feet and 2 inches. First of all, I cannot use 3 feet and 2 inches. I have to convert it to a decimal number. So 2 inches divide 12 will give you a decimal. So this side will be 3.167 feet. And this one will be 3.167 feet. If you would like to figure out the perimeter of this square, it will be 3.167 times 4, because we have 4 sides for the rectangle, for the square. Then I will multiply this perimeter by the total thickness of the footing. I think the total thickness of the footing can be figured out from the elevation. We are given here 1 feet thickness. This is the total thickness of your footing. So time 1 feet. If you multiply these together, I can get 12.67 square feet. This is the total surface area of the 4 sides for formwork for the footing. That makes sense? If you have many footing, like 9 footing, 18 footing, 20 footings, any number of footing, we can multiply this number by the total number of footing. But so far, for only 1 footing, we will use 12.67 square feet formwork. For the column, as I mentioned, your column looks like this. I can figure out the dimension of the cross section, this dimension and this dimension from the plane. If you look to this plane, we are given this is the column. This square is your column. 16 inch by 16 inch. So we have 16 inch by 16 inch. And the total height of this column can be figured out from the elevation. From this point to the top surface of the footing, the total height of your column is 8 feet. So I have the total height of the column is 8 feet. So keep in your mind, the 2 drawings must be given because some of the dimensions can be figured out from the plan and the other dimensions can be figured out from the elevation. Both of them will help you to figure out the required dimensions. So if you would like to get the area of the formwork for this column, we need to get the perimeter of this cross section, just perimeter. It will be 16 inch times 4 because we have 4 sides. This one, this one, this one, this one can give you the perimeter. And I will multiply this perimeter for this square by the total height of the column, which is 8 feet. We have a little mistake here because this 16 in inch, I need to divide it by 12 to convert it to feet. So 16 divide 12 times 4, this is the perimeter, times 8, this is the total height, will give you 42.67 square feet for one column. So this column with its feet, with its footing, so the area total for the column and the footing, both of them will be this area 12.67 plus 42.67. Let me check. 16 divided 12 is 1 and 0.33 times 4 times 8. Yes, we are right. So this number plus 12.67, I got here 55.3. So I need 55.3 square feet for just only one footing with its column. If this arrangement is repeated many times in your building with the same dimensions, I can multiply this number by how many columns and the footing. That makes sense? So the column and the footing is repeated. So how many times? I can multiply how many times by 55.3. But so far, we are given only one footing and one column, and we need to figure out the required formula. Anybody has any question? Anybody has any question? We did this example before. We have the same, but right now we are talking about footing only. So for example, footing F1 is equal 4 feet 9 inch times 4 feet 9 inch times 18. So I can figure out the area for footing F1. And this F1 is repeated many times. We have here F1, we have here F1 2 times. And also for F2 is repeated many times. And F3 repeated many times. So I can find out the area required for one footing, then multiply it by the number of footing. I can figure out the total area of the formwork. There is another example. We have something called head wall. It's very important to understand what is the meaning of head wall. At the entrance or exit of storm sewer pipeline, we can find this structure which is called head wall. So if the water is trying to get in the pipe, or even if the water is trying to get out as exit from the pipe, we are constructing this head wall to prevent any corrosion in the soil. This is not our topic today for this course. We have this structure, this concrete structure, and we need to build it. So I need to figure out how much area of the formwork to order how much plywood to construct this formwork. Does that make sense? So if you figure out the head wall, I need to construct this wall and this wall and this wall. We have 3 walls. We have 3 walls. If we start with this wall, we need to construct a formwork on this side. That's right. We need to construct a formwork at this side. And I will construct the same formwork on the back here. Then I can pour my concrete in between. That makes sense? So if you look to the elevation, if you are standing on front of this wall and look, you will see this elevation. If you look from the top, if you are at the top of this wall and look, you will see this plane. That makes sense? So what is the length of this side? It will be 5 feet, given in the elevation, 5 feet. What is the height at this side? It will be 2 feet. What is the length of this side? Or even this side as a projection, horizontal projection, it will be 10 feet. So the area of this trapezoid, area 1, equal 5 feet plus 2 feet divide 2 times the height in between, 10 feet. Hey, if you have trapezoid, looks like this. This is H1, this is H2, this is distance in between. So the area of this trapezoid will be H1 plus H2 divide 2 times the distance in between, which is D. That makes sense? But keep in your mind, this trapezoid is repeated one more time in the back. So I will multiply it by 2. Keep in your mind what you did at this wall will be repeated on the other wall. So I will multiply it by another 2. So please pay more attention. We need to understand what's going on. 100% the isometric or this is picture will not given, but we are learning right now. I am trying to construct this wall, so I need to build up a formwork at this side. The area of this formwork on this side equal this expression, the area of trapezoid. Then I need to construct another formwork on the back here to be able to pour concrete in between. So I multiplied this area by 2. What I did for this side of the wall will be done the same on the other side. So I have another 2. So far, I calculated the total required area for formwork for just only the 2 walls, this one and this one, or this one and this one. So the total will be 5 plus 2 divide 2 times 10 times 4 equal 140 square feet. Keep in your mind, we need to construct another wall, which is this one. So from this side, it's a square, looks like a square, 5 feet by 5 feet. Does that make sense? 5 feet by 5 feet. So 5 feet by 5 feet. But keep in your mind, I need to subtract the area of the pipe because the area of this pipe will be opening, will not be considered. So the area of this pipe is by D. Area of any diameter, area of any circle with a diameter D equal by D square. I'm sorry, by divide 4 D square. If it's radius, it will be by R square. That makes sense? So anybody in this meeting can tell me what is the diameter of this pipe? Do you think the diameter is given? Or I can figure it out? Any help? This total height is 5.
Yeah, there's 1 foot.
Yes, I will leave 1 feet from this side and another 1 feet from the top. That means the remaining will be the diameter of your pipe will be 3 feet. That makes sense? One more side. We have this square. This side length equal 5, this side length equal 5, and I will construct an opening to put your pipe. I will leave here 1 feet and another 1 feet here. So the remaining dimension will be the diameter of your pipe, which is 3 feet. So the total height will be 5 feet. Does that make sense? So I need to subtract by divide 4 times diameter square. This is only the area outside the diameter. Outside the circle, I'm sorry. Keep in your mind, I need to multiply this total area by 2 because I need to construct this formwork one more time on the back and then pour concrete in between. Does that make sense? For any wall, we learned this. For any wall, we need to construct the formwork from the 2 sides and then pour concrete in between. That makes sense? So the area on the front is area of a square minus area of circle. Then I will multiply it by 2 to get the total area. So 5 times 5 minus by divide 4 times 2 equal 35.8. So the total area required, total area of formwork for this way end wall or head wall will be 140 plus 35.8. It will be 175.8 square feet. And keep in your mind, actually the diameter of the storm drain outlet, the pipe is given 36 feet. Anyway, we need to figure out, we need to consider 10% waste. Keep in your mind, we are ordering plywood. This plywood, that makes sense because we should have waste. We cannot consider every single part of this plywood. So I will consider 10% extra for the waste. So the area of plywood I need to order will be 175.8 times 1.1 will give you 193.4 square feet. So I can figure out the cost of the material of this formwork. But for me, I need to figure out what is the total area for the formwork required to build up this head wall. We talked about the steel reinforcement. And we learned that if you would like to figure out the quantity takeoff for your steel reinforcement, we need to figure out how much weight of steel reinforcement. This table is giving you what is the size of your rebar, what is the number. We have different numbers, number 3, number 4, number 5, until number 18, which is the biggest diameter. And here is the weight of unit feet length. If you have a piece of steel with a unit feet or unit length, 1 feet length, the weight of this rebar is given in this table based on the size of your rebar. For example, if you have rebar number 14, that means this rebar with the length, only length 1 feet, will give you a weight equal 7.65 pound. So this weight is bound barefoot, 1 pound for only 1 feet length. If you are able to figure out the total length of your rebar, if you multiply this total length by the weight of 1 unit length, you can get the total weight of the rebar, 1 rebar. If you multiply this total weight for 1 rebar by how many times this rebar is repeated, you can figure out the total amount of steel rebars by weight. And this total amount will be in pounds. If you divide this amount of pounds by 2,000, you can convert it to ton, American ton. That makes sense? Let's do some example. We did this example last meeting. We have a concrete filled drilled shaft with 40 feet deep, and we have 10 vertical rebars, number 10. And we have ties repeated every 4 feet, number 5. And the diameter of this shaft equal 1.5 feet, and we figured out how much steel reinforcement needed. We have more examples. Let's do this example. One of you will say, hey, we did this example just a few minutes ago. Yes, we did, but we did it only for formwork. Just formwork to construct this footing and this column. But right now, I will figure out how much steel reinforcement needed to construct this footing and this column. Actually, I'm looking for columns only, not footing, only column. What is the amount of steel rebars in the concrete column only? So keep in your mind, this shape represents the cross section of your column. In the real life, this cross section represents this one. And these points represent the steel reinforcement. We have vertical steel rebar. Vertical steel rebar. If you are watching from the top, you will see the steel rebar looks like a point. That makes sense? So if you look to your plan, I can tell you we have number 6 rebar. And we have number 3 ties. That makes sense? Keep in your mind, your steel reinforcement for the column is not only the longitudinal rebar, the vertical rebar. No, we have, yes, the vertical rebars, which is number 6. But also we have ties. Can you see this rectangle or this square of the rebar? Can you see them? They are repeated. These are called tie or ties. They are number 3. And they are this square. So keep in your mind, the outer square is the perimeter of your concrete. The inner square, which is the red one, is the tie. And the dotted, these dotted are the steel rebars, which is in a vertical direction. So first step, you need to understand what is the meaning of this shape. So let's start to figure out the vertical reinforcement or rebars. Your rebars are number 6. How many? From this cross section, how many dotted you have? We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 rebars. And each rebar is number 6. What is the length of each rebar? The length will be figured out from the elevation. Because the length of your rebar equals the height of your column. As you see here, this rebar will extend to the total height of your column. That makes sense? So the length will be 8 feet. The steel rebar starting from the top of the footing to the end of the column, it will be around 8 feet. 8 feet. That makes sense? So right now, what is the weight of 1 unit length of number 6? We have a steel rebar number 6, this one. So this one will give you a weight equal 1.502. So the weight of the steel rebar equal 1.502. This is the weight pound for each 1 foot length. The total length of this rebar is 8 feet. So I can figure out the total weight of only one rebar. And this rebar is repeated 8 times. Based on this cross section, we have 8 rebars or 8 points inside the square. If you multiply these numbers together, 1.502 times 8 feet times 8 times equal 96.1 pound. We need to order 96.1 pound of steel rebars to construct the vertical reinforcement. Then I need to figure out the weight of the ties. We are using a number 3 ties. Number 3, this information is given here on the drawing. Number 3. Anybody can help me to figure out what is the length of this tie? Keep in your mind, this tie looks like square. And this square is repeated on the column, is repeated. This square is repeated. So I think the total length of this red square will equal approximately. It's not exactly, because the outer dimension of the column is 16. The inner can be less than 16. If you consider it 16, that's fine. This point is very important. Hey, the dimension of your column is given by 16 inch by 16 inch. Based on the concrete design, I will leave 2 inch from each side, 2 inch concrete cover from each side, 2 inch concrete cover from each side. Then I can construct the tie. Your tie will be located at this location. Then I can put the steel rebar that we consider. Does that make sense? So if you would like to figure out what is the perimeter of this tie, to be more accurate, I cannot use 16 and 16. But the perimeter equal, I think, if you leave 2 inch from here and 2 inch from here, so the remaining will be around 12 inch. Times 4. Because we have 4 sides. And I will divide this 12 by 12. So the perimeter of one tie equal 4 feet. This is the total length of one tie. This length of this tie equal 4 feet. How many? What is the number of these ties? How many? I need to go back to the drawing and figure this out. What do you think? We have 3 ties at the bottom. 1, 2, 3. And we have 3 ties at the top. 1, 2, 3. Then we have ties every 6 inch, and the bottom every 3 inch. So we need to figure this out. Here is the top, the elevation of the column, and the total length is 8 feet. I will put 1, 2, 3, 1, 2, 3, 1, 2, 3. 3 inch, 3 inch, 3 inch. And we have also 3 at the top. 3 inch, 3 inch, 3 inch. And then I will put my ties every 6 inch. That makes sense? Based on the given information, the ties here every 6 inch, but at the top we have only 3 ties additional every 3 inch. I can say, okay, I have a different technique. I will consider my ties every 6 inch for the whole height. That makes sense? So how many number of these ties? I think I will have 16 spacing, means we will have 17 ties. If you have 16 spacing, that means I will have 17 ties. I will add 3 ties at the top and another 3 ties at the bottom, so I can figure out the total number of ties, 23. That makes sense? So regularly we have number 3 ties every 6 inch, but for shear or something else for design, I will add additional 3 ties at the bottom and additional 3 ties at the top based on the given information. So the total number is 23. So right now, the weight for number 3, go back to the table. For number 3, the weight is 0.376 pound for each unit length. If you multiply this weight for each 1 feet by the total length of 1 tie, will give you the weight of 1 tie. And then I will multiply this weight for 1 tie by the number of ties, which is 23. So the total weight of ties will equal 0.376 times 4 feet times how many? 23 ties. 0.376 times 4 times 23 will equal 34.6 pound. I need to order 34.6 pound of number 3 to construct my ties. And I need to order 96.1 pound of number 6 to construct my steel reinforcement. Guys, I would like to give you a hint. I will not be more tough about the total number of ties. If you put 24, if you put 22, that will be fine. That makes sense? So no restriction about the total number. But if you put 20 or 15 or 10, that means you have a mistake. That makes sense? I'm not saying 23 must be 23. No, can be 24, can be 22. That's fine. This little difference will not affect on the final answer. Not a big deal. That makes sense? Do you have any question regarding the steel reinforcement for your column? I would like to do this example. This is a footing. And I would like to help you to figure out how we can consider the required steel reinforcement for a footing, isolated footing. We have isolated footing 5 feet by 4 feet by 1 feet thickness. So keep in your mind, I would like to explain it in more details. This is the footing. Looks like this. The given dimensions are the dimension for the concrete. We have 5 feet, this length, 4 feet, this length, and 1 feet, this thickness. Keep in your mind, the steel reinforcement for the footing looks like this. I will construct a steel rebar in this dimension with a little leg here and a little leg here. This leg, your steel rebar will looks like this. This little leg not equal exactly the thickness of the footing. It will be half, maybe 0.5 feet. This one approximately 0.5 feet. And the length of this part from here to here will be approximately 4 feet. It's not exactly, but we can assume it 4 feet. So I can figure out what is the total length of this steel rebar. The total length will be 4 feet plus 0.5 plus 0.5 will be around 5 feet. So if you look here, the steel rebar looks like a U shape, looks like this. This little leg is not equal the total thickness of the concrete. We can assume it half. So if the total is 1 feet, 1 foot, 1 feet, so the length of the rebar will be 0.5. Keep in your mind, this rebar is number 6. And this rebar is repeated every 10th inch. So this steel rebar is repeated every 10 inch, is repeated every 10 inch, is repeated every 10 inch. So the spacing is 10 inch, 10 inch, 10 inch. If you would like to figure out how many of this steel rebar, the number will be 5 feet divided by 10 inch plus 1. What? Yeah, because 10 inch is repeated along the length of 5 feet, which is this direction. So this 5 feet will be multiplied by 12 to be converted to inch, divided by 10 inch. But this division will give you how many spacing. But the actual number of your rebars will equal the number of spacing plus 1. Does that make sense? So 5 feet times 12 divided by 10 plus 1. That means I will need 7 rebars with total length equal 5 feet repeated in this direction. So the first weight number 1 equal number 6. I need to go back to the table. Number 6, here you go. 1.502. The total length for one rebar is 5 feet. And this rebar is repeated 7 times. Then I can tell you what is the weight, the first weight of this steel rebar. 52.6 pound. One more time. But on the other direction. We will construct steel rebar this way. because we need to construct mesh. Can you see we have a steel rebar in this way? So I will put my rebar looks like this. This little height will be have thickness 0.5 feet. And we have here also 0.5 feet. And keep in your mind, this length of the rebar will equal to this side of the footing, 5 feet. So the total length of this rebar will be 6 feet. Does that make sense? And the size of this rebar also number 6. And this rebar will be repeated every 10 inch. Every 10 inch we will have rebar. Every 10 inch we will have rebar. So how many number of rebars will equal? This rebar will be repeated in this side, which is 4 feet. So 4 feet times 12 to be converted to inch divided by 10 inch plus 1. Because the first term will give you the number of spacing, I will need to add 1 to get the number of rebars. So 4 times 12 divided by 10 plus 1 approximately will be 6 rebars. So the weight number 2 equal the weight of 1 feet length time total length of this rebar 6 feet time this rebar repeated 6 times. I can give you the total weight. I'm sorry, 54.1. So the total weight of a steel reinforcement needed for 1 footing will be 52.6 plus 54.1 will equal 106.7 pound. So I need to order 106.7 pound of steel reinforcement number 6 to construct only 1 footing. If you have many footing, we need to multiply this number by how many footing of this size. So guys, I would like to highlight this point because footing is very important. You need to understand how to figure out the steel reinforcement for your footing. The footing is defined by the concrete dimension. So if you have L or B and the L and the thickness T. So I would like to construct a steel rebar in this direction. Can you know what is the length of this rebar? Yes, equal B plus half T plus half T. This half T and this half. Does that make sense? And then this rebar is repeated many times, repeated. If you can figure out what is the spacing between this rebar, I can tell you how many number. Your number equal the length L divided by spacing plus 1, because L divided spacing will give you how many spacing. But if you add 1, that means we can get the how many rebars. What I did for these rebars must be repeated because I should have rebars on this side also. The length of this rebar equal L plus half T plus half T, which is 1T. And this rebar is repeated. This rebar is repeated. This rebar is repeated. So how many? Equal. This rebar is repeated in the direction of B. So B divided spacing. What is the spacing between rebar? Plus 1 will give you the number. If you know what is the total length, what is the weight of each 1 feet, and what is the number, you can get the total weight for this rebar and the total weight for this rebar. Add them together, you can get the total weight of steel rebars. That makes sense. And I'm giving you this sketch just for your information. But in the exam or homework, I will not give you this sketch. I just will give you these information to read them. Does that make sense? This is how to figure out the weight of steel rebars to construct your concrete footing. We have homework, 3 problems only. The first one looks like your solved examples in the lecture notes. We have concrete filled drilled shaft with a total length 35 feet deep, and we have vertical steel rebars and the ties. We need to figure out how much steel reinforcement in ton. And we have this retaining wall with these details. You need to figure out how much steel rebar we need and how much concrete also. Concrete and rebar. We are given this concrete wall with 60 feet length and 7.5 height, and the thickness of this wall is 8 inch. We need to figure out how much steel rebar we need in pound, how much cubic yard of concrete, how much square feet needed for the formwork.